Okay, welcome to our PSLE Science again. Thanks for the 88 viewers who view our video. I don't even know who you are, but thanks for viewing. Yay! They are very happy that someone actually watched our videos. So, we're going to do the next question. Okay, so this next question is a continuation from last week, the turtle question. We have question 35 right now, okay? How do we go to turtle question? Oh. Okay, we should be looking at this. Okay, this one. Alright? So this is about, okay, let's take a look at the question. I haven't read yet. So limit pour 500 ml of water into a container. So it's level at first. Then lowered a stone. So when you put stone, the water level will increase, correct? Because stone takes up space. So next, she emptied the container and placed a stopper at one end. So she drew a line to show where is it, right? And she poured 500 ml of water into the container through opening B. Draw in the diagram the water level in the container. What? Do you understand what they said? Do you understand what they did? Huh? You don't understand what they did? Okay, let me read again. I also don't really understand. So at first there's water. Okay, let's see. At first there's water. Water. Put stone. Water level go up. Now water level goes up both sides. Okay? Both sides. Water level increase. So next she emptied the container and placed a stopper at opening A. Then she poured 500 ml of water into the container through opening B. Oh, okay. So what will it look like? So what happens is that now you put a stopper here and then you pour water inside from here. So when water pours in from this side, is it going to fill up the whole thing? No, why? Yeah, there's air, okay? And then the other thing is that the water level here is higher than this. Here higher than this. How come? Because the air over here takes up the space. Okay, so therefore water cannot, the water level will be different. Okay, so explain your answer. So let's see how to explain the answer, right? So explain your answer for part B. So for part B, the water level at B is higher. We said the water level at B is higher than at A. Why? Why is that so? Because air cannot escape as the stopper prevents it from escaping. Hence it takes up the space. Oops. Okay, hence it takes up the space above Q. Okay, so it takes up the space above Q. There's no way you can push the air out. Okay, there's no way you can push the air out. It's because of the fact that the air takes up space. Yeah, that's about it. So this one question. So this question is slightly different. It's not the usual stuff that we see all the time, okay? But I think it's nevertheless still doable. It's just we gotta read the thing and fully understand. Okay, next one. So next one, what's the aim of Schwann's experiment? So what's the difference is one is bubble wrap, while the other one is bubble wrap, and then the other one is just hot water. Is it hot or cold? Cold water, 16 degrees Celsius. What's the aim of Schwann's experiment? What do you think is the aim? To find out what? What's the aim? To find out if air bubble or pockets of air is a poor conductor of heat. Okay, so we want to find out if air is a poor conductor of heat. Actually, it's to find out if it will affect the temperature. Whether it affects the loss of heat or gain heat. Okay, it's to find out if air is a poor conductor. Actually, okay, let me give a better answer. It's not just a poor conductor. If bubbles or the air bubble will affect the temperature of water. That's it. Okay? Right? That's it. It's quite straightforward. There's nothing else. So next. So in the graph above, draw the line where that represents the temperature changes in the water in setup X. Okay, I think it's done for you. It's the one at the bottom, right? The one at the bottom is the X. Why? It's because it does not. The temperature remains cold. Why is it cold? It's because it does not absorb heat so fast. Poor conductor, right? So it doesn't absorb the heat. So nature replaces the water in both setups with 100 cm cube of water at 100 degrees Celsius. In which setup will the water be warmer? So now instead of cold water, we put warm water. So which one will the water be warmer? Right? In which one will the water be warmer? Setup X, right? Okay, why? So water in setup X will be warmer. So why? Because air is a poor conductor of heat. The bubble wrap prevents heat loss. Okay? So the bubble wrap prevents heat loss, therefore the temperature is still the same. Or it's not the same, it just loses heat slower. Right? The rate of heat loss is slower. Okay, next. Houses in countries where there are 4 seasons usually install insulation layers. Explain how these air pockets benefit the people living in the house during the hotter and colder months. Okay, so when it's cold, why is it good? When it's very cold.
The house.
The house will not lose heat so fast, okay? So the benefit of cold, the house will not lose heat. Hence, occupants will remain warm. Is it the same for our houses here? You look at all these houses. What do they have at the top? Oh, that's nice, you see? Ooh, check out the houses. Okay, houses over here. The roof, what shape?
What?
What's the shape of the roof? Look at that, what's the shape of the roof? Triangle. Who stays in the triangle? Nobody. It's just pockets of air. Okay? It's just pockets of air inside the triangle. Now, how about above here? Above here, on top. Are there people staying on top here? On top also triangle, in case you don't know. Here. One big triangle. Anybody stay there? No, I don't stay there. Why would I stay there? You know what? At night I climb the stair. I go out and sleep. No, I don't stay there. Nobody stays there. Okay? It's blank one. It's just one big triangle, empty space. Okay, but you look at this house. This one. Is it triangle?
What house?
There, the grey colour one. No triangle, no? You know what that means?
Why?
At top very hot. The one at the top is very hot. So I don't know who stays there. Maybe they are whoever they don't like. They say, you stay here, or it becomes like a oven. You know? Yeah. So the top, it's very hot. Why? It prevents heat loss. Okay, but during the in Singapore, is it to prevent heat loss? No, Singapore is because it's the reverse. It's very hot. Okay, so it's actually the second box. What's the benefit during hot weather? What's the benefit during hot weather? Prevent heat gain. Okay, it prevents heat gain. To the house, so the occupants can remain cool, right? But that place is very hot one, right? So they call it the attic. And then usually, what do people store things? I mean, what do people use that place for?
Why?
Storage. Put things. So put things. Right? When you put things, does your whatever thing in your storeroom, do they worry about being hot? No. Do they worry about being cold? No. Just put it there. Okay. But you don't put plastic bag there. You know why? I put plastic bag in my storeroom. It's very hot. Right? They crumble, become biscuit. I'm not kidding. Okay? Yeah. So you put all the plastic bag there, it will crumble because the place absorb all the heat. Right? So the fella, whoever is staying there, is very, very hot. Must switch on aircon all the time. Okay, so nobody stays there except for rats and insects and cockroaches and maybe some birds. Maybe some birds. Baby cannot stay inside. Right, but in fact on top is very, very high one. I ever saw the aircon guy. The aircon guy climb inside and then he disappeared. There's like, hey, where you go? He opened one of the hole. This one is open. And then he climbed all the way. Then he came out from the other side. Because it's one big space at the top. Humongous space. Very big space. Okay? It's a big space at the top. Unbelievably big. Okay? So next. So we are done with this, right? This is the attic insulation, air pockets that act as insulators. Next. Question 37. Yes, thanks for helping me. So we have two water beaker A and B, and then two tray X and Y, two tubes. So Jane suspended two trays X and Y of the same size at the same distance from the ends of a T tube. The tube is attached to a conical flask which contains some water. Tube has a conical flask. Okay, so the two beakers were empty. Jane heated the water. After 5 minutes, she observed that more water collected in beaker B than A. Oh, how come beaker B has more water? Why beaker B has more water? Beaker B. Why beaker B has more water?
Because
Yeah? The what? So tray Y is cooler. You mean what? Colder surface area, and therefore colder than what? Yes, the rate of condensation is faster, right? So we say that the tray Y. Did you press on me? Yeah, thank you very much. So tray Y has a lower temperature than tray X. This causes the rate of condensation to be faster. Hence, more water is collected in beaker B. Okay, more water in beaker B than A. So it's about the rate of condensation. But B. So part B. So at the end of 10 minutes, Jane noticed fewer water droplets forming on both X and Y. Give a reason. Do you know? This seldom asked. This one seldom asked. But do you know? How come less and less? Less. Is there a word called lesser? Or is it we call it
Less.
less? Is there a word called lesser? Don't have English. Moral? Is there less is the opposite of more, right? So is there a moral? No, it's just less and less. Why does it become less? The what? Very good. The tray gain heat and therefore unable to condense the water vapor. Very good. So the tray eventually gained heat and was unable to condense the hot water vapor. Okay, so it's condensation. Less condensation, cannot condense because itself it become hot like the zombie. Last night I watched a zombie movie. Yeah, the zombie. How does zombie become zombie? How does human being become zombie? The zombie bite the human being, and the human being becomes zombie. Right? That's usually the case, right? Okay. What do you press? Okay, don't worry. Okay, so it's the same over here, right? What happened? Wait. What happened to this thing was that the tray, at first it's cold, okay, then after it became hot. So after it became hot, it cannot condense also. So it's like it has become a zombie. You understand? Like the temperature became the same as the water vapor. So it cannot condense anymore because it gained heat. It must be cold before it can help to condense. Zombie is like the zombie bite the human being, right? Human being becomes zombie, right? So the hot water vapor go and change the temperature of the tray, so it becomes hot as well. Okay, anyway, are you okay? Yeah. Then move. Let's go, next one. So when the pendulum... Okay, what is the force that caused the pendulum bob to swing back and forth? Back and forth. Why does it swing back and forth? What force? Gravitational force, very good. So next one, based on the graph, what type of energy, gravitational potential or kinetic do X and Y represent? So the graph shows the energy, one is going up and down. So you see the energy, right? This is down, then up. Then the other one is up and down. This is when it's swinging between A, B to C, and C, B back to A. Alright, so at point A, what energy does it have? Is it the kinetic energy or gravitational potential energy at point A? Does it have more gravitational or kinetic? Gravitational. So which curve shows at point A there is more gravitational? X, right? That means X is the gravitational potential energy. Okay, so X is the GPE. Now in exam you got to write the whole thing. Y will be the KE. Okay? Exam you got to write out you cannot write KE and GPE over here because you may not know what is KE, what is GPE. You may think that KE is coconut energy or GPE is GoPro energy, right? So you must write out the whole thing. Okay, next. Okay, we do fast. Later we can do some other questions. Yay. Okay, next is an electricity question. So based on the result of our experiment conclusion, can Xue draw about the electrical conductor of material A, B, D? Okay, we gotta study this a while. Study this a bit, Oh man. She positioned them in different parts of an electric circuit, sure. If the light bulbs. Okay, so let's look at the first example. The first example is the bulbs lit up W, Y, and Z. X never light up. Okay, if X never light up, what do you think is... Okay, what is A and B? Are A and B conductors? We look at first example. Now, this one never light up. X never light up. Right? So A and B must be conductors. Is it okay? So that's what we deduce from the first diagram. How about C and D? One of them is insulator. One of them, but do you know which one? Don't know. So we look at the next arrangement. So in the next arrangement, Y never light up. Next arrangement, Y didn't light up. So this one never light up. So if that never, so who is the bad boy? C is the culprit. Okay, then how about B, D, and A? Are they conductors? Very good. So we can deduce now, right? So we can now deduce that C is a insulator, while the rest of the materials A, B, and D can conduct electricity. Okay? So that is the conclusion. Right? So that is the conclusion. Two more. Okay, so next. So when Xue arranged materials A, B, C, and D the third time, she found that none of it light up. Right in the box, how she may have arranged. None of it light up. See over here.
It's not here, I see. This L.
I'm seeing from opposite. Wait.
It's not.
Okay, you're right. Okay, what's C?
Yeah.
Yes. Okay, so C is over there. Why? Because that's where all electric current has to pass through. That point is the point where all electricity has to pass through. So the rest, does it matter how you put A, B, C? Doesn't matter. Okay, because the rest are all conductors, so you can just put it like random or in different location, the A, B, C. Only C, just make sure C is over there. Okay, because none of it like lit up. So explain your answer. So we gotta explain our answer. Alright, why do we put it that way? Because okay, so when C is just beside the batteries, it causes an open circuit the entire setup. Okay, so this is the sound of the motorbike. Okay, so this is the the open circuit. So they test you on what's the closed and open circuit. When C is at that point, it becomes an open circuit. Open circuit. Okay? So the entire setup, you don't have any, is a light, it's lit. Last page. Very long question. So state a property of paper A. Number of sheets of paper A counted by the data with 0.05. Amount of light. Oh, light can pass through. Light can pass through. So what is the property of paper A? Is translucent. Okay. Oh, where did the thing go? So paper is translucent because some light can pass through. So explain why it's not possible for the data logger to count more than 5 sheets of paper at a time. Okay, so no light can pass through as the paper is too thick, hence data logger okay. Okay, it's not detect. Yeah, I cannot detect. So other than keeping the distance between the light source and the light sensors fixed, what's another thing that must be kept the same? The thickness of the paper must be the same. Thickness of the paper has to be the same. Alright, so because you want to test the translucent and how much whether it's opaque or translucent or transparent, the thickness must be the same. If the thickness is slightly different, you get different effects. The results are different. Next, last one. Let's go. Okay, so from the graph, what will be the extension of spring X when a 50-gram weight is attached to the spring? So we look at spring X, 50 gram is at about 7 cm. So what's the extension? The keyword is extension. What's the original length of the spring? What's the original length? So when you put 50 grams, we're gonna expand a bit more. When you put 50 grams, it's somewhere here in the middle. Okay, so X is, oh no, it's about here. Sorry, it's about here. X at 50 grams. That's how many centimeters? 9, about 9. But is that the extension? What's the original length of the spring X? 2, right? So original is 2, and then now it became 9. So what is the extension? Minus. So 9 take away 2, this is 7. Okay, which spring X or Y is used in the spring balance above? Which one? Should be X. Why is X? Spring balance by length. Because it's extension. So we say that the graph shows that spring X stretch Okay, so the graph shows the spring X stretched as the mass increases. So it's not compression, it's a stretching, right? Which is exactly what the diagram is showing. The diagram is the spring balance is a extension one, it's not the compression one. Okay, so that's what the diagram shows. And the final question for today, no, not today. The final question for this. Yeah, before we take a short break, it's time to break. So last question for spring Y, what is the relationship between the length and the mass?
Relationship question.
Yeah, that means the longer the spring or the the lighter the mass, what happens? The lighter the mass,
The longer string.
yeah, the longer the spring. Okay, so this is the relationship. We talk about one go up, the other go down, or vice versa. Alright, so that is the end of this paper. So far we have done a lot. This is from CHIJ and Girl. We've done a lot of papers already. We want to find out how do you feel so far. Let's start from today you all wear black and white. Okay, Isabel, how do you feel so far? How many papers have you done? Yourself, I mean over here we've done about 10, more than 10 already. Okay, yourself, how about yourself? How many papers have you done? 60, yeah? 6, okay. So it's about 16, okay? How about ST? You cannot count? As in do too many cannot count, or you finger cannot count? Finger cannot count. So you might have done a lot, right? Must have done a lot. Okay, how do you feel? Do you feel that there's improvement for science? Like the speed of answering questions? You must remember when you first start, right? When you were at least about 6 or 7 months ago. Was it slower? Or now is it faster? Do you find that now you're answering faster? So it works, the more you do, the faster you get. Okay? And do you realize that you don't have to read every single word, right? Do you read like take a long time? Do you do that? Oh, she said no. She didn't say no. No. Why? Why no? Last time do you have to read every single? Yeah, I have to, right? So now why you don't have to do that? You do so many, and then they look very familiar. Waste time. Familiar. Yeah. Okay, it's not waste time, it's she finds them very familiar, therefore she can go very fast. Okay? So that is the trick, and that is my strategy. Glad that it's working. Okay, so now we're gonna take a short break and we'll do the next paper. Okay?